Hello students, welcome back to Chapter 7 discussion on interval estimation. My apologies for how we ended the last video, but we will continue. We were working on the example of the restaurant association, and we calculated the confidence interval 2.76 plus or minus 0.43, and we're just going back and just making sure we understand what the different parts of that confidence interval include. So the standard error we calculated, the margin of error. Let's see what's up with my pen. Oops, I know why. I gotta do this. There we go. Margin of error. Margin of error would equal that the t-value 2.539 times the standard error 0.1677, so that equals 0.43. The upper limit, the confidence interval is 2.76 plus 0.43, that would be the upper limit, and then the lower limit 2.76 minus 0.43, so the upper limit would equal 3.19. The lower limit would equal 2.33. So how confident are we that the population mean is within that interval? We are building a 98% confidence interval. So this interval, we are left with the understanding that the population mean is somewhere within this limit. The population mean is between $2 or 2.33 times to 3.19 times. So young married couples with a 98% level of confidence, we believe that the young married couples eat out between 2.33 to 3.19 times. So let's go on to the third type of confidence interval. This is a confidence interval dealing with proportion. Proportion is going to be basically a percentage of people or items that exhibits a certain characteristic. So the confidence interval process is the same as the confidence intervals that we've already studied. So the needed values, we're going to need, we need from the sample, P bar, which is our sample proportion. We're going to need a sample size. How many items did we survey, for example? And we're going to need a level of confidence. That's our confidence interval. Now this confidence interval estimation for proportions always use a Z value. So the standard error of the proportion, we're going to write it, where's my pen? We're going to write it like this. Standard error of the proportion, standard deviation of all the proportion values, so standard error of the proportion is going to equal the square root of the sample size times 1 minus the sample size, all divided by n. And of course, if we have, if n is known, then we have to adjust the standard error by multiplying, by basically going like this, the same first part, 1 minus p over the square root of n, multiplied by that correction factor. So the confidence interval formula is sample proportion plus or minus a Z value certain Z value that's based on half of alpha, multiplied by the standard error of the proportion. Or we can rewrite that to be Z alpha over 2 multiplied by everything that the standard error proportion equals. And of course, adjusting it if we know the population size. So let's take a look at an example. The example is HSBC Bank. They want to determine the proportion of women employed in the public sector. So they take a random sample of 150 public service employees, which included 51 women, construct a 90% confidence interval for the proportion of women working in the public sector. So this question, we are trying to calculate this value, which is the population proportion. HSBC wants to know this value. We don't know this value. We're not going to go and ask every single public sector employee. So we take a sample because it saves time, saves money, but it's not 100% accurate. But it's going to develop an estimate with that interval with a certain degree of confidence. So the sample proportion is 51, but 51 is not a proportion. You know, this is the number of women in the survey, in the sample, but we need a proportion number. So this is one thing we've got to do. 51 divided by the sample size. And we get about 34%. We're going to keep it as a decimal. Oops, my bad, 0.34. So remember that with proportions, it has to be listed as a decimal number less than 1 or as a percentage less than 100%. 51 is not the proportion. 51 is how many women were in the sample. Sample size 150. We want a 90% confidence interval and our Z number. Now here's one little friendly hint and tip about remembering the Z values. So remember, we have the normal distribution table, Appendix B. We have the T distribution table, Appendix C. But if we go back to that appendix, which looks like, oops, where was it? Looks like this, and that's our Appendix C. There's the T distribution values right from the course package, page 127. I've copied it over here. I just want to point out that these are T values. Let's point this out in black here. These here, all the way down here, all the way to that last row, these are T values. The last row we have Z values. 1.28, 1.64, 1.96, 2.33, and 2.58. So on your T distribution chart, even the one in the course package, let's bring that up again. Course package, the very last row has your Z values you need. Now what we have to do is just remember the confidence interval per column. So I'm just going to quickly erase this if I can. Bear with me while I try out my new fancy eraser. There we go. Let's get this back in here. So this is something you can do on your Appendix C T distribution chart you have. We know that when the alpha value here, this is, remember, this is alpha over 2, so we multiply that 0.1, we get 0.2 or 20%. So this represents a confidence interval of 80%. This represents a confidence interval of 90%. The middle one is 95%. This is 98%, and the last one here is 99%. So they go in order from 80 to the larger one, 99%. 80% confidence interval is not used a lot, but these last four are used. So this is a way we can just use to remember what the columns represent for confidence intervals. So we need a 90% confidence interval. So our Z value, this is a confidence interval for the proportion, so this is the value we're going to use, 1.64. Let's go back in here, 1.64. So we're going to build our confidence interval, which uses, this formula here. And we're going to put in the standard error all at the same time, divided by n. So this value here is 34%. We're going to use as a decimal, plus or minus 1.64, and then the square root of 0.34 times 1 minus 0.34, let's just put that in there, 0.66, divided by 150. So we do this multiplication and process, we get 0.34 plus or minus 0.06. Or if we want, we can change that to a percent, 34% plus or minus 6%. So what does the standard error equal? The standard error, we just calculated that. I'll just put it back on here so we get used to seeing this. 0.34 times 1 minus 0.34, 0.66, divided by 150, and that's the square root of everything. I should write that better. This basically equals 0.039. We'll go. Margin of error, that's when we bring in the Z value times the standard error. And that's what gives us approximately 6%. The upper limit is 0.34 plus 0.06. The lower limit, we subtract it, 0.34 minus 0.06, and basically left with 40%. And this would be 28%, 0.28. How confident are you that the population proportion, I got to change that, my bad, is within this interval? We are 90% confident that the population proportion, this value, is somewhere within the range 28% to 40%. So let's go on to the second example here. Actually, this is the last section for this chapter, and based on the time, let's continue this in the next video.